Graph Convolutional Networks, GCNs, Part 1, Why Graphs? Stay tuned for more tutorials at learnai_CV. In this video you will learn what a graph is, where to find graphs, and why we must study graphs. A graph consists of a set of entities and a set of connections. Entities are called nodes or vertices and connections are called edges or links. The world around us is composed of entities that interact with each other in different ways. Graphs are all around us. Real-world objects are often defined in terms of their connections to other things. A set of objects, and the connections between them, are naturally expressed as a graph. We can store information in nodes, edges, or the entire graph. A molecule is a set of two or more atoms that are bound to each other by chemical bonds, and each molecule has its own properties. Molecules are the building blocks of matter. It's a very convenient and common abstraction to describe the molecule as a graph, where nodes are atoms and edges are covalent or other types of bonds. Roads in a city and intersection between them form the road network in the city. A road network can be represented as a graph with the nodes being the traffic intersections, the edges being the road segments, and the features of the edges being some attribute of a road segment. Such a representation enables researchers to analyze road networks in a consistent way from the perspectives of graph and machine learning. The traffic flow in one road depends on the traffic volume on other roads. Every day millions of people sign up for various social networks where they can connect with each other, share posts and videos, or comments on a post. A social network graph is a graph where the nodes represent people and the lines between nodes, called edges, represent social connections between them, such as friendship or working together on a project. Social networks are important to social scientists interested in how people interact as well as companies trying to target consumers for advertising. For instance, if advertisers connect up 3 people as friends, co-workers, or family members, and 2 of them buy the advertiser's product, then they may choose to spend more in advertising to the third person, on the belief that this target has a high propensity to buy their product. These days, people can buy their products online, and the recommender systems suggest new products to customers based on the history of their shopping habits. Getting an e-commerce system to function reliably is not a trivial task. It is a sophisticated ecosystem that involves understanding complex dynamics between the customers, products, fulfillment methods, inventory planning, pricing, etc. Knowing which products to recommend to the customer requires e-commerce researchers to have a thorough perspective. Customer needs. Why is the customer here? Do they prefer a certain brand? What are their attributes? The relationship between the entities involved is multidimensional, hence, standard tabular data formats do not scale well to represent these complex interactions. A graph data structure, on the other hand, offers a more intuitive way to represent and visualize such multidimensional relationships. Unlike in other data representation formats, relationships are first-class citizens in a graph structure, making them ideal candidates for representing complex data interactions. In a graph, the entities are represented as nodes or vertices, and the relationship between them is represented as edges. The nodes and edges can have properties that provide additional information about the nodes themselves or the connection between two nodes. A citation graph is a graph that describes the citations within a collection of documents. Each node in the graph represents a document in the collection, and each edge is directed from one document toward another that it cites. Citation graphs are used in the citation analysis and academic search tools. They are predicted to become more useful in the future as the body of published research grows. There is a huge amount of data in the mentioned examples. Furthermore, new data is produced in various areas. Access to large volumes of data enables researchers to analyze and address a lot of applications. This type of data can be modeled as a graph. The nodes and the connection between them can be cyber or physical. The graphs are comprehensive and flexible tools for representing the data in a network. Stay tuned for more tutorials at learnai_CV. Graph Convolutional Networks, GCNs, Part 2, Types of Graphs, Stay tuned for more tutorials at learnai_CV. In this video you will learn simple graphs, directed graphs, bipartite graphs, signed graphs, dynamic graphs, multidimensional graphs, heterogeneous graphs, and hypergraphs. Before we go through different types of graphs, we mention types of edges. An edge can be directed, where the edge has a source node and a destination node. In this case, information flows from the source node to the destination node. An edge can also be undirected, where there is no notion of source or destination nodes, and information flows both directions. Note that having a single undirected edge is equivalent to having two directed edge. A simple edges connects only two nodes. A hyperedge is a generalization, a simple edge that connects an arbitrary number of nodes. We show an hyperedge as a set of nodes. A simple graph consists of a set of nodes and a set of undirected edges. All nodes and all edges in a simple graph are of the same type. A graph with directed edges is called a directed graph. A social network is a graph in which the nodes represent the people and the edges are the social connections between people. These graphs can be undirected or directed graphs. The act of connection in LinkedIn is an undirected edge, while the act of following on Instagram is a directed edge. In a city, the streets can be one-way or two-way. For modeling the streets in a city, as a graph, the streets are modeled as a directed edge. A bipartite graph is a graph whose nodes can be divided into two disjoint sets x and y such that every edge connects a vertex in x to one in y. For example, in an e-commerce graph, the users and the products are two disjoint sets, and there is no edge between two users or two products. In a signed graph, each edge associates with a positive or negative sign. Each edge can only be either positive or negative. Signed graphs are used in social networks to represent types of relationships between people. The act of following and blocking on Instagram can be viewed as positive and negative edges, respectively. In some applications, the graph under study may be static. The structure of the graph and features of the nodes and edges are constant. In a dynamic graph, at least one of the data such as nodes, edges, edge weights, node features, and edge features can be added, deleted, or changed over time. In domains where dynamic graphs emerge, extracting important information within the evolution of the graph is crucial in making accurate predictions. We can model human activity recognition from videos by a dynamic graph. We need to extract the key point of the human from each frame of the video. The key points represent the nodes of the graphs, and the edges of the graphs are the skeleton of the human. In each frame, the locations of the nodes are changing. Temporal and spatial information of the nodes are used to classify the human activity. Another example of dynamic graphs is the urban road network, where the nodes are the different places of the city, and the roads are the edges of the graph. The traffic flow in each road is the property of the edge that is changing constantly. Social networks are dynamic graphs in which new users and connections are added. In real-world applications, multiple interactions can exist between two nodes. For example, on Instagram, users can comment on a post or can like that or can share the post with other users. In these graphs, the edge is modeled as a vector of different properties. The graphs described so far have only one type of node. However, in many applications such as relations between authors, papers, and journals, there are more than one type of nodes and edges. This kind of graph is called a heterogeneous graph. Heterogeneous graphs, known as heterogeneous information networks, are seen in many real-world applications. Heterogeneous graphs consist of different types of nodes and relations and can model rich semantic and structural information. In a hypergraph, there is at least one hyperedge. A hyperedge links more than two nodes. Groups in WhatsApp can be considered as a hyperedge. Stay tuned for more tutorials at learnai_CV.